Hi, this is Mrs. La Barbara. Today's topic is describing motion with the equations. The objectives for today are know the kinematic equations and be able to apply kinematic equations to solve problems. Here are kinematic equations. First one, average velocity or average speed equals the total distance divided by time. These equations, for one thing, they are all for constant acceleration. So for constant acceleration, average speed also equals to initial plus final divided by 2. By the way, this equation is not in your reference table. I highly suggest you write it on your reference table. If we combine these two equations, we can have another one, d equals average velocity times the time. This is a very convenient equation. You don't actually need this equation to solve problems. All the other ones, if you have, you can solve it. But this is just make the whole process a lot easier, that equation. Next equation is average acceleration is change velocity over time. That means it's final minus initial. Change is the difference. Divided by time, you rearrange this equation, you'll have VF equals VI plus A times delta T. Next one, D equals to BIT plus 1/2 AT squared. On your reference table, I don't think the reference table has delta, but in these equations, that's what T means, the time difference. But a lot of times, time starts with 0, so the difference and the time are the same. But you should know in this equation, what is delta T mean? That's the time difference between the initial and the final. And last equation is VF squared equals VI squared plus 2A times delta D. So this equation, we have a name. This is called a timeless equation because this equation has no time. So whenever we see an equation has no time, right away, it should occur to you that's the equation we use. Okay, again, just to review, what are all this symbol means? D is for displacement or can be distance. A is for acceleration, T is for time. This V with a bar means average velocity, initial velocity, VF is final velocity. The strategy for solving problems. To simplify it, it's IC. What does I means? Identify. Identify what? The list of given information in variable form and list unknown information in variable form. Use a chart. So write down all the things that you're supposed to use, such as initial velocity, final velocity, average velocity, time, acceleration, distance or displacement. That's identify for I. C, C-S-E-E. C means to set up. Choose the equation based on the known and unknown from identify from whatever is you known from here. Next one, execute a solution. That means really do the math. Last one, evaluate. Does the answer make sense? So I see. That's the process. Let's do an example. So a car having initial speed of 60 meters per second is uniformly brought to rest in 4 seconds. How far does the car travel in this 4-second interval? So the process is IC, right? Identify. What is the given, what's unknown? Write down the chart. So what's given? Initial 60 meters comes to a stop, comes to rest. That's your final velocity. In the time period is 4 seconds. Question is, how far does the car travel? What is the distance? So you know VI, you know VF, you know time. How do you find the distance? Now let's see. If you know initial and final, you can find average velocity. Average velocity is this two added together divided by 2. Next one is to choose an equation. What's the equation? Average D equals average velocity times time. So average velocity times time, execute is to solve. 8 meters per second times 4 seconds, you should have 32 meters. Evaluate. Does this answer make sense? 32 meters? Well, it does. Okay, the answer does make sense. 32 meters, think about it, the car traveling 60 meters per second. So if it travels at constant speed, it will travel 60 meters every second. For 4 seconds, it will travel 16 times 4, 64 meters. But it's accelerating. It's accelerating in the negative direction. In a way, it's decelerating because it comes to a stop. So your distance should be less than 64 meters. Another example, a skier starts from rest, skis straight down a slope 50 meters long in 5 seconds. What is the magnitude of the acceleration of the skier? So use the process called IC, identify. Write down what you know. See this word rest? That is a key word. That means velocity equals to 0. Your initial velocity is 0. We don't know the final. The next number we know is 50 meters long. That is your distance. The next number we know is 5 seconds. What is the acceleration? What is A equals to? Look at the equations in your reference table. See what equation you can use to find acceleration. So the equation is this. D equals VIT plus 1/2 AT squared. How do we know? Because A is the only thing you don't know. You know D, you know VI, you know T. So the only thing you don't know is A. That's the one you use. Next one is execute. That means you substitute and solve. 50 meters equals 0, VI times 5. So that means the first term is 0. How do you solve for A? Okay, you get rid of that 0, get rid of the units, just write a mathematical equation, make it easier for you to solve. Multiply 2 on both sides, right? Then divide by 25. You should have A equals to 4 meters per second squared. Again, evaluate the answer. Does the answer make sense? So because you are going downhill, going straight down, right? So if you're going down, you should have positive acceleration because you're getting faster and faster. Next example, a race car starting from rest. Again, so velocity is 0. Think about it, is that initial or final? Accelerates uniformly at a rate of 4.9 meters per second squared. What is this quantity? What is the car's speed? So VF. As it travels 200 meters. That's your D. Identify, set up, execute, and evaluate. See in this equation, there is no time, so we use timeless equation. Again, first identify what is given to you. Initial is 0 because it's at rest. VF is the one we don't know. The next one says acceleration is 4.9. Another quantity given to you is 200 meters. That's your D. You don't know the time, so that's the equation we use, timeless equation. VF squared equals VI squared plus 2AD. Substitute and solve. This is substitute to solve it. Okay, so you get rid of this term, then you square root on both sides. Your answer should have a unit, 44.3 meters per second. Does the answer make sense? Yes, it does, because it should get faster and faster. So this is bigger than 0. Next one, average velocity of constant acceleration. So we know average velocity, we already have shown you, average velocity is initial plus final divided by 2, the average of two numbers. Now on the graph, this is velocity versus time graph. Average velocity should be the point right in the middle. That's average velocity, right in the middle between the minimum and the maximum. So in this case, it's 10. In this case, should be right in the middle between 0 and 25. So that should give you 12.5. That is average velocity. So here is the question. What are the distance traveled in 5 seconds for both of the following motion? This motion, that motion. How do we find the distance or displacement? Well, remember we said in VT graph or speed versus time graph, the area represents the displacement. So the area, this is a triangle. The area is 1/2 base times height. 1/2 base, in this case, is 5 seconds. Height is 20 meters per second. That is 50 meters. That's one way to do it. What is another way? Use the equation. D equals average velocity times time. We already know the average. Average is 10. We already know the time. So here is just another way. You have the same answer, 50 meters. Another way to solve the same problem. This one also, try to solve it in two ways, the area and the average velocity. Then check the answer. You should have 62.5 meters. Let's take a look at this example. According to the diagram, what is the average velocity and acceleration during 6 seconds? The first 6 seconds, average velocity is between 0 and 15, should be 7.5, right over here, right? 7.5. What is the acceleration? Acceleration is the slope in velocity versus time graph. So average velocity 7.5, slope is 15, rise over run. 15 divided by 6 give you 2.5. Next one, what is the average velocity during 6 to 10 seconds? From 6 to 10 seconds, velocity didn't change. It equals to 15 meters per second. What is acceleration? Slope equals to 0, so there is no change, there is no acceleration. Next one, what is the displacement during the entire 10 seconds? So for displacement, again, there are two ways. First is to find the area of this trapezoid. Another way is to use the average velocity. The problem is you'll have two average velocities. How do you find the average of the two averages? Well, it depends on the time. So the average velocity for the whole period from 0 to 6 seconds is 7.5. You use this times 6. Now from 6 to 10 seconds, in the 4-second interval, the average is 15. So you multiply this, add them together, divide by 10. So you average from 0 to 10 seconds, average velocity is 10.5 meters per second. Then you can find the distance. Average velocity times time, you should have 105 meters. If this sounds confusing to you, you can always use the area of trapezoid, or in this case, you can use the area of big rectangle minus triangle, or use the small rectangle plus the triangle. I just used the area of trapezoid, so I have the same answer. That's it for today. Thanks for watching. See you next time.